Let's have a look at where the data analysis data comes from our devices, which are ESP32s. Sends IoT data up to Google IoT through PubSub into Firestore and gets saved as a measurement collection, so a collection of measurement data. The measurement data is read by a Firebase function, runs hourly and creates hourly and daily summaries. So that's another collection. Our overview page uses the measurement data to give an immediate view of the data. Our trend page shows trend data coming out of the measurement summaries, and then our data extract uses both sets of data. Let's have a look at data analysis. So you can get to data analysis from the data analysis menu item. By default, it'll drop you into data analysis, which has 3 tabs. So you've got the overview tab, the trends tab, and the extract tab. Let's have a look at the overview. On the overview tab, by default you come into this and it'll just show you the number of successful tests. Now this is shown as a heat map, so it's showing the devices D1 to D4 in my case versus the probes that are being run. It shows you by default the measurement of successful tests, and it's a count over the last hour, so I can see how many of these probes were actually successfully run in the last hour on the different devices. Some of the changes you can make, or some of the settings you can change here, you can change from, say, measuring successful types to, say, round-trip latency. I also want to change to value, and one note, when you change to value, instead of looking at aggregate of the last hour, it just gets to the latest value, so the latest value that was returned by the probe and device for that combination. So we see here we're getting ping measurements in milliseconds. See, in this case there's a wide range of values, so sometimes in that case it's easier to, or shows better the values if you change to a 5-color map. So you see where there's a large variation in values. Having multiple colors can just sort of highlight different ranges within the complete range there. You can also do things like include filters, so I may want to compare just for a particular probe. So I'm going to just select Ping New Zealand, and here I can just compare what different results I'm getting for the round-trip latency from all these various devices just for that one probe. So this is a simple way sort of comparing values from for a particular probe from a lot of devices, which is kind of the point of the whole thing. Note one more thing you can do here, and let me just close up the options again, is you can quickly go into the trends information by clicking on one of the cells in the heat map. So if I want to see what's the trends on D02 for the Ping New Zealand probe, I can click on that and it'll drop me into the trends ready to go. So now we're in trends. One big difference from overview is it's based on measurement summaries. So remember from the introduction, measurement summaries are generated by a background cron job on the server, both for hourly aggregate summaries and for daily aggregate summaries. So a big difference from overview, where overview is based on just the latest measurements, raw measurements coming in from the probes. So we see here we came in here showing device D02 for the probe Ping New Zealand, and it's showing the values for the last 6 hours, which are pretty stable. So something we can do here in options is, a lot of times I want to see, I found this most useful, is to see kind of the distribution of measurements. So from, say, percentile 25 up to percentile 75. Still they're very close together, so I'm not seeing much variation there. So one thing you may want to do is use the auto scale to drop the Y scale just to the lowest value So there we see more obvious difference in round trip latency. Again, they're very close together. So let's try, instead of ping New Zealand, let's try our DARS. And instead of round trip latency, let's look at bandwidth. So here's more typical sort of thing you see with the chart, where the lower percentiles is quite obvious here, higher percentiles fairly obvious too, and like you'd expect the 50th percentiles in the middle. So nice way of sort of seeing how much there's a distribution of measurements each hour. Like I said, you can look for longer periods of time, so you can look over 24 hours. 24 hours it still shows hourly summaries. 7 days also shows hourly summaries, but once you get up to 30 days it changes to daily summaries. And I don't have 30 days worth of values, but shows you about 15 days worth here. So other things you can do is look at the same values, say from a different device. So we see there's a slight difference when I'm using D01 device rather than D02. Let's just go back down to 24 hours, and I'm going to look at D03. I'm not sure whether I've got many values here. So you can see I only actually turned that one on earlier this morning, so I only seen the last few hours of results. So the last function on data analysis is extract, which is on the extract tab, and just does what it says. You can select data to be extracted. It brings the data down as a CSV file, and the idea is that for more unique or custom visualizations, you can bring it down to a tool like Power BI or Spotfire, or even bring it into Excel and use some of the graphing tools and filtering tools in there. So the way you use this is first select a starting date from the calendar. I'm just going to choose today's date. That's the date relative to the local time, so it would be 12 AM my local time for this date is when it starts. Number of hours of data to extract, I'm just going to choose 4 hours because sometimes you can grab a lot of data. The type of data to extract, so like I said before, there's 3 types of measurement data. There's the raw measurements that come directly from the probes. That has the majority of the data. And then there's the summarized versions, the hourly summaries and the daily summaries. So I'm going to grab the raw measurements, then however many rows you want to extract. Now the recommendation is first do this for low number of rows just to see what the data looks like. You're pulling down to make sure you got the data you want, and then if that looks okay, then choose a much higher maximum rows to get all the data, and then choose the measurement type. So I'm going to choose round trip latency. But when I hit extract data, it tells me how many rows I've extracted and gives me a link here where I can download the data. So I'm going to click on that, and you see here it's downloaded the data as a CSV file. I'm going to click on that, and that actually opens up Excel. So this is just the data as it is coming in from the probe. So the device ID, the probe name, the probe unique ID, the round trip latency as the type because that's what I selected. The value, you can actually select all types, so but your file will be a lot larger, but I just selected round trip latency. The actual value, so this would be the round trip latency in milliseconds, the local date and time, and the UMT date and time of when the data was collected. And then I just also extract hour and minute as separate columns. That makes it easier for some of the data analysis external programs, especially for things like Power BI. Just to let you know, I've also got an example of where I work on some of this data in the developer blogs. So you can go out there and look in the development blogs, and you'll see using things like Power BI to work with this data. Finally, look at some of the miscellaneous functions. So one, as a user, you have access to your profile. So some of this is technical information. Most useful information is these flags is administrator. So if the person is an administrator of the system, then this is set to yes. Is activated. So when you first sign into the system, that really just registers you as a user, but doesn't give you access to the system until administrator activates you. If you're coming from a authentication system that has your photo in it, then your photo is here. Otherwise, it just does a generic image based on your initials. And then the thing that you can change as a user is your location. So you see in here, if I pull down the location, it gives me a map, and I can click on the map to set my location. And that's used when you go into the home page. If you have set a default location, it doesn't have to be your exact location, then it'll show you probes that are around you. So for example, if I go to the home page, it's showing that same location, but shows the probes that are located within about 40 or 50 miles of what your default location is. The other function that is for administrators, so because I am an administrator, when I sign in I see this user management menu item. People don't normally have that. So if you click on that, it gives you a list of users who are in the system. And again, this application is meant to be for use within an enterprise, so we don't expect to have millions of users, maybe more, for this sort of application, which is a fairly technical one. You'd only have 10, 20 users. But if I wanted to change information about a user, then I can click on the user's email. So I'm going to do it with this test01 example. And the information I can change as an administrator is whether this person is an administrator, so I can promote someone to an administrator. I can't do this to myself, only to other people. Whether they're activated, so as I said before, when people first sign into the system, they get registered in the system but are inactive, and an administrator still needs to activate them to allow them to use the system. And finally, the administrator can also update a person's default location. That's the whole system. There's an about box, gives you some useful links in there for things like getting back to LupinCorp, which has the developer blogs on it, version number, and some contact information for me.